The last example that I want to cover is example number 9 in the applications. All right, I will let you see what it is. A Norman window has the outline of a semicircle on top of a rectangle. Suppose there is 8 plus pi meters of wood trim available. Discuss why a window designer might want to maximize the area of the window. Then find the dimensions of the rectangle and hence the semicircle that will maximize the area of the window. So we have to form a window, all right? And the window looks like this. It's a semicircle on top of a rectangle. Okay, and this is the wood trim that will be put to make the window. All right, of course, excuse the mess. So let's start analyzing. We have 8 plus pi wood trim. So all of this is 8 plus pi. How much is all of this? For the rectangle, if this is x, this is y, this is x, all of this is y. For the semicircle, y is the diameter. So the radius r is y over 2. Now, how can I go around this window? I need 2x plus 2y, 2x plus 2y, and I need the circumference of the circle, not all of it, the circumference of the semicircle, which is half the circumference of the circle. And what is the circumference of the circle? Usually 2 pi r. So 2 pi. And what is r in the problem that we have over here? Y over 2. This is equal to how much? This is equal to 8 plus pi. So 2x plus 2y plus pi y over 2 is equal to 8 plus pi. So, in other words, if I want to write y in terms of x, it will be 2y plus pi over 2y is equal to 8 plus pi minus 2x. Y equals 8 plus pi minus 2x over 2 plus pi over 2 or 4 plus pi over 2, which is written as 16 plus pi minus 4x over 4 plus pi. Or you can write x in terms of y, whatever you want. Both of them are okay. If you write y in terms of x, that's what you will get. And if you write x in terms of y, you will get the following. If you write x in terms of y, 8 plus pi minus 2y minus pi over 2y, that's 2x. So x equals 4 plus pi over 2 minus y minus pi over 4y. So you see whichever is easier for you and use it. But now what do we want to maximize? We want the area of the window to be maximized. What is the area of the window? It's the area of the rectangle, which is x times y, plus the area of the semicircle. What's the area of a circle? Pi r squared. The area of a semicircle is half pi r squared. So it's x times y plus pi y squared over 4 times 2 over 8. It's easier to substitute x in terms of y rather than substitute y in terms of x in two places. So ay will be equal to 4y plus pi over 2y minus y squared minus pi over 4y squared plus pi over 8y squared. So this, I directly multiplied every single term here by y to make things faster. Now, is there any limitations on x and y or w and so on? Is there any هيدا? Of course they should be greater than 0. I don't bother الصراحة. I don't bother with finding what they are over here. So we know that they should be 2x should be less than 8 plus pi. So x should be less than 4 plus pi over 2. But let's assume we didn't know how to calculate it. What we will just be strict with is that y has to be greater than 0. Alright, because if y equals 0, everything will be equal to 0. All the area will be equal to 0. So y has to be strictly greater than 0. A prime of y is equal to 4 plus pi over 2 minus 2y minus 2 pi over 4, which is pi over 2. Come on, you can simplify this here. 4 plus pi over 2y minus y squared minus pi over 4 plus pi over 8 is minus pi over 8. So you get 4 when you get the derivative plus pi over 2 minus 2y minus 2 times pi over 8, which is pi over 4y. For this is always defined. It's a polynomial, linear. The only thing I can find is zeros. This will be 4 plus pi over 2 minus 2y minus pi over 4y equals 0. So minus 2y minus pi over 4y is equal to minus 4 minus pi over 2. This means that y equals minus 4 minus pi over 2 divided by minus 2 minus pi over 4. This is twice that, so the answer is plus 2. Alright, then you make a table of variation. This y equals 2. X will be equal to 4 plus pi over 2 minus 2. So 2 plus pi over 2 minus pi over 4 times 2, which is minus pi over 2. This with this will cancel. So x will also be equal to 2. And r will be equal to y over 2, which is 1. So those are the dimensions. But we have to show on the table of variation y from 0 to infinity. 2, we get a prime at y. At 2 it's equal to 0. Before 2 at 1 we plug it, we find that 4 plus pi over 2 minus 2 minus pi over 4 is positive. At, let's say, bigger than 2, middle at 4, we get 4 plus pi over 2 minus 8 minus pi, so again it is negative. So increasing then decreasing. Zoom out. This is not only a local max, it's an absolute max for those dimensions that we have over here. So this is another example where we prove how we maximize things, how we minimize things, what's the benefit of these things when it comes to engineering and architecture and so on. So like, thank you so much for listening. This is section 3.7.